Hi there, and welcome to this lesson. In this lesson, we'll be learning about surds, okay? And under surds, we'll be learning about the basic operations. We'll be learning about basic operations on surds. And at this point, I'd remind you to set the video to play in 1080p HD, okay? You can do so via the settings icon on the bottom right. And then as the lesson progresses, if you have any issues at all or if anything comes off as unclear, please feel free to get in touch, okay? You can do so via the course dashboard. Okay, so basic operations and surds. Let's jump right into the lesson. Now, in this lesson, we're pretty much in the last lesson, we talked about surds and we learned what surds are. And then we also learned how to express surds in their basic form, okay? And that would be basically we're going to apply that knowledge to something very important, because like we know surds are pretty much just numbers, and like any other number we can actually do basic arithmetic operations on them. So we can add them, we can subtract them, we can multiply them, and we can divide them. And that's pretty much what we're going to be learning in this lesson. Okay, how to add surds, how to subtract surds, how to multiply them, and how to divide them. Now, before we start adding and subtracting and multiplying and dividing, there's something we need to learn. There's something we need to know, and we need to know about similar surds. Okay, very important. Now, similar surds are surds which are multiples of the same surd. Okay, for example, you could have 2 root 2, 5 root 2, and 11 root 2. Now these are multiples of the surd root 2, okay? Because 2 root 2 is 2 root 2 times 2, 5 root 2 is 5 root 2, 2 root 2 times 5, and 11 root 2 is root 2 times 11, okay? So these are multiples of the same surd, root 2. Now, we're going to apply this knowledge to working surds, because it's similar surds, very important to performing basic operations on surds. And I'm going to compare operations of surds, operation on surds, to algebraic operations. Okay, now watch this. From basic algebra, we know that if we have 3x plus 2x, it would have 5x. Okay, so 3x plus 2x is 5x. Now, I want you to compare x to root 2. Okay, let's say x is root 2. We'd have 3 root 2 plus 2 root 2 equals 5 root 2. And the basic operations of surds are very similar to algebraic operations. So the way you add and subtract x's and y's is actually quite similar to the way you add and subtract surds. Okay, so let's consider something else. If we have 7y minus 4y, it gives us 3y. Okay, and basically if you compare this to a surd, let's assume we have y as root 3. You can have 7 root 3 minus 4 root 3, and this gives you 3 root 3. Okay, and this is a very simple, very simple, straightforward processes. Now let's try something else. If you have 3x plus 4y, if you remember from algebra, what is 3x plus 4y? We can't add 3x and 4y. Okay, and in the same way, you can't add 3 root 2 and 4 root 3. Okay, you can, because why? They're not similar surds. Before you can perform any basic operation, before you can perform addition and subtraction, on surds, on any surds, they have to be similar surds. And just like you can't add x and y, you can't add root 2 and root 3. Okay, now let's move on to multiplication and division. Very similar, also the same. Now if you have 9x times 5x, basically how do you go about solving 9x times 5x? You multiply the 9 and the 5, and that gives you 45, and the x and the x, and that gives you x squared. Okay, similarly, if you have 9 root 2 multiplying 5 root 2, you multiply the 9 and the 5, it gives you 45. Okay, you multiply the root 2 and the root 2, and it gives you root 2 squared. Okay, and root 2 squared is 2, So that gives you 45 times 2, which will give you a final answer 90. Now, if you have 3x multiplying 5y, you can actually multiply 3x and 5y in algebra, because you multiply the 3 and the 5, and that gives you 15, and you multiply the x and the y, and that gives you xy. Similarly, you can, okay, you can't add or subtract, but you can multiply surds that are not similar surds, okay? For example, you can multiply root 2 and root 3. And basically, just like you had in the algebraic operation we just did, you can also have 3 root 2 multiplying 5 root 3, and you multiply the 3 and the 5, it gives you 15, and then you multiply the surds root 2 root 3, and if you remember the distributive property that we discussed in the last lesson, you can have that as square root of 2 times 3, and that gives you 15 root 6. Okay, let's do some division. So if you have 6x divided by 2x, you basically have 6 divided by 2 as 3, and then you have the x's canceling each other, and you end up with a final answer 3. Similarly, if you have 6 root 2 divided by 2 root 2, you basically have the 6 divided by 2 gives you 3, and pretty much the root 2 cancels each other out. Okay, now what if you have something like 10xy divided by 5y? Okay, you basically have, you divide the 10 by the 5, and that gives you 2. You divide the xy by the y, and that gives you x, so you end up with 2x. All right, now similarly, if you have 10 root 6, okay, we're comparing 6 to xy because x is 2 and y is 3, so we have root 6 there, okay, and basically you have 10 root 6 divided by 2 root 3. You basically say the full numbers out there. You have 10 divided by 2, it will give you 5, and then you have root 6 divided by root 3, it gives you root 2. And that is how you perform basic operations on surds. So we've learned to add them, we've learned to subtract them, we've learned which surds we can add and which ones we can't. Okay, so basically, for you to add or subtract surds, very important law, they have to be similar surds. Just like you can't add x and y, you can't add root 2 and root 3. Okay, and then multiplication and division is pretty much following the same system. So anytime you're working with surds, just have that algebra mindset at the back of your mind. They're actually very similar, complete total resemblance, okay, no difference at all to the way we work algebra. Okay, so let's go ahead and solve some examples. So example 1, and example 1 says simplify root 20 plus root 63 plus root 75 plus 2 root 28. Okay, so let's go ahead and solve this. Now, the first thing we want to do here is we obviously need to get these look like very large surds. We need to simplify them, and we need to get them in their basic forms. Okay, for example, if you look at root 20, root 20 is 4 times 5. I think I can get that to 2 root 5. Okay, if you know from the last lesson. Root 63 is 9 times 7, and I think I can get that to 3 root 7. Root 75 is 3 times 25, so I can get that to 5 root 3, and root 28 is 4 times 7, so I can get that to 2 root 7. Okay, and basically you have 2 root 5 plus 3 root 7 plus 5 root 3, and then you have 2 times 2 root 7, i.e. 4 root 7. Okay, so after that, the next thing I want to do is I want to simplify this. Okay, so I have 2 root 5 plus 3 root 7 plus 5 root 3 minus 4 root 7. And just in the same, when you work in algebra, if you have 5x plus 3y plus let's assign z to that, 5z minus 4y. Okay, you basically bring the y's together. Okay, you collect like terms, and you do pretty much the same thing when you're working with surds. You collect like terms, so we're going to bring the 3 root 7 and the minus 4 root 7 together. Okay, and then when we work that out, what we have in the end is we have 2 root 5 plus, or sorry, minus root 7. Okay, because 3 root 7 minus 4 root 7 is minus root 7 plus 5 root 3, and that is our final answer. Okay, let's move on. Now I have another example here, example 2. And example 2 says simplify 3 root 10 divided by 2 root 45. How will we go about solving this? Okay, now the first thing we obviously need to do there is we need to express these numbers in their basic forms. Okay, so we pretty much can't do anything about root 10 at the top there, but we definitely can do something about root 45 at the bottom, and we can have root 45 as 3 root 5, and when we multiply that with 2 we end up with 6 root 5. Okay, and then the next thing we want to do, we basically just need to simplify this out, and we divide just like a fraction. Okay, we can actually cross out, so we'll work with the full numbers. Okay, so we work with 3 and 6 first, and I can go 3 here 1, okay, and 3 here 2. Okay, and then I want to work with the surds now, and I'm going to divide with root 5, and I can go root 5 here 1. Okay, because root 5 divided by root 5 is 1, and then I can go root 5 in 10, it'll give me root 2. So what I have at the top is 1 times root 2, and what I have at the bottom is 2, and I can get my final answer as root 2 over 2. It's that simple, very straightforward. There really isn't much to it. Okay, so let's do another example. Example 3. Okay, and example 3 says simplify root 2 multiplying 3 root 2 plus root 3. Basically we have just a small expansion here. Okay, and if you were doing this in algebra, it pretty much wouldn't take you anything to do, and just like I said before, it's actually no different. Okay, so if you had x plus 3 plus 2x in a bracket, and I ask you to simplify it, you just do a very simple expansion and you get your answer. And that's pretty much exactly what we're going to do here. Okay, and basically we have step 1, we have a question there, and then what we have is we have root 2 multiplying 3 root 2, it gives us 3 root 6, no sorry, 3 root 4. All right, we have 3 root 4, and we have 3 root 4 plus, oh no, we have root 3, not, we have root 3 multiplying 3 root 2 plus root 3. Okay, and basically what that gives us is we have 3 root 6 plus 3. Okay, and then we can actually factorize this using 3. All right, and basically we bring out 3 outside the bracket, and what we end up is 3 outside the bracket root 6 plus 1. Okay, and that's pretty much straightforward. There really isn't much to it. All right, now let's go over to our last example. Okay, example 4, and example 4 is a very interesting one. Okay, it's pretty much the same with algebra. It looks old, but then it's actually quite easy. Okay, so simplify 8 minus 3 root 6, all in brackets, multiplying 2 root 3 minus 3 root 2, all in brackets. Okay, and just think of it as an x plus 2y multiplying x minus y. It's pretty much a very straightforward expansion process. Okay, and let's just go about, let's just jump into doing that right now. So step 1, and step 1 is the expansion. Okay, so we have 8 just like you would do in algebra. You take the first term 8 and you multiply it by the second bracket. Okay, so we have 8 multiplying 2 root 3 minus 3 root 2, and then we have minus 3 root 6 multiplying 2 root 3 minus 3 root 2. Okay, just like we do in algebra. And then when we expand that out, what we have is 8 times 2 root 3 is 16 root 3. Okay, that's 8 times 2, 16 root 3. And then we have 8 minus 8 times 3 is 24. Okay, so we have 24 root 2 there. Okay, and let's move into the minus 3 root 6. So we have minus 3 root 6 multiplying 2 root 3. You multiply the two numbers outside, you have minus 6. Okay, that's minus 3 times 2, so you have minus 6, and then you multiply the surds, and you have that 6 times 3, it gives you 18. So what you have here is you have 6 on the outside and you have 18 as the surd, so 6 root 18. You do the same for the second surd, and basically we have minus 3 root 6 multiplying minus 3 root 2, and basically we multiply minus 3 and minus 3, we get 9, so plus 9. Okay, and then when you multiply the surds, that's root 6 and root 2, you end up with root 12. Okay, so very simple expansion, just like pretty much very similar to what you do if you had an algebraic expression. Okay, now step 2. Now we pretty much just need to simplify this out. Okay, as a surd, basically just get these in their basic forms first. All right, so we have 16 root 3 minus 24 root 2 minus 6 root 18 plus 9 root 12. Okay, now I pretty much can't do anything about 16 root 3 and 24 root 2, but then we can simplify 6 root 18 because we know 18 is 9 times 2. Okay, and we have a 9 there. 9 is a perfect square. And we can also simplify 12 because 12 is 4 times 3. 4 is also a perfect square, and we'll just go about doing that now. Okay, so these stay the same. And then we have, when you simplify that, you have 6, the 6 first, multiplying, when you simplify root 18, you have 3 root 2. Okay, plus you have the 9 outside, and when you simplify root 12, you have multiplying 2 root 3. Okay, and then we just need to solve that out. So we have 6 times 3 equals 18, so we have 18 root 2 plus 9 times 2 is also 18, funny enough. So we have 18 root 3. Okay, so what do we need to do at this point? At this point, we simply need to collect like terms. Okay, so 16 root 3, I'm going to bring that 18, 8 plus 18 root 3 over there. So I have plus 18 root 3, and then I bring minus 24 root 2 minus 18 root 2. Okay, and then I end up with the final answer. When you add 16 plus 18, it gives you 34. So 34 root 3 and minus 24 root 2 minus 18 root 2, you just work minus 24 minus 18, you have 42 root 2, and that is your final answer. And that's pretty much how you go about solving surds. Okay, very similar to algebra. Just remember that it's very similar to algebra. Once you know how to do your algebra, you pretty much shouldn't have any problems doing any operations on surds. And that will be the end of this lesson. Okay, and I'll see you soon. Bye for now.